So Soliton as a company was first created in Japan in 1979, and in that period has grown to a company with over 750 people, and we have a network of worldwide offices. Now, Soliton originally made its name in IT security, but about 10 years ago we launched what we refer to as our broadcast department. So we developed a technology that allows live streaming over multiple cellular connections. So our original customers was in the broadcast space, so we were selling to broadcasters doing live news, to sports production companies doing live sports. But as you can imagine with any company, Soliton really prides itself on innovation. So the product evolved. Our original hardware transmitters were known as the ZOW, and we're on our third generation of ZOW technology now as a hardware transmitter. And the markets have also changed as well. So we've actually moved from broadcast, we still have broadcast customers, but also we're doing mobile surveillance. So this is surveillance for government agencies and law enforcement. But more recently as well, we've started doing more in the realms of what we call teleoperations and teledriving. And this is an emerging market where basically people want to remote control devices, whether it's robotic devices, whether it's drones, whether it's cars. And actually this is where the whole telesurgery thing has started to make a real name for itself for Soliton in terms of live streaming. Because what people need is not just reliability, not just good quality video, but ultra low latency. And this is where really Soliton has really made a name for itself, is the ultra low latency, with probably the lowest latency of any device when it comes to live streaming. And since that time, actually very recently, we've started also developing a software version known as the ZOW SDK. And Kerim, perhaps my colleague, can talk a little bit about the SDK version that we just launched.
Yes, telesurgery came into our radar as an interesting case while we were exploring the teleoperation business applications. Since we developed our ultra-low latency technology, we upgraded our protocol, and now we are not just sending video but also control signal. So the teleoperation cases were interesting for us, and telesurgery really stood out as a unique case. So we started exploring, how we can contribute to communication between surgery robots. And then we realized that sending video with ultra low latency is actually critically important to make the telesurgery reliable and eventually possible. So that's why we are exploring our part in this telesurgery industry and emerging fields related to that.
Well, I think in order to understand where video streaming comes in to telesurgery and robotic surgeries, to really define what is telesurgery. So telesurgery refers to the use of advanced technology that allows a surgeon to perform surgical procedures on a patient who is in a different physical location. This is made possible through the use of robotic surgical systems that include one or more robotic arms, a master controller, and where we fit in, obviously we have multiple live video streams and a sensory system that provides real-time feedback to the surgeon. But it's these video streams and a return network path that are critical to safe operation of a remote telesurgery robot. It needs to be highly reliable, good quality, but especially the ultra-low latency video needs to be effective. Telesurgery can provide improved access to specialized medical care. It can reduce travel time and costs. It can increase efficiency and improve surgical outcomes. It is beneficial for patients living in rural or remote areas and can enable surgeons to perform procedures with greater precision and accuracy. As well as video streaming for the telesurgery from the robot itself, there are other nice to haves when it comes to video streaming as well. So the video stream gives a real-time feel and acts as a great training tool where other remote people can learn, or where other remotely based surgeons are needed for second opinions or for reviewing new procedures. And other surgeons obviously are quite often there and where they're present in that additional consultative role. So the live streaming from a robotic telesurgery perspective obviously has many different applications. So there are many applications why we need telesurgery. A patient is a long distance away from the specialist surgeon, maybe the operation is highly specialized, maybe the patient is unable to travel for it, maybe it's in a war zone even. So we need to virtually bring the surgeon and the patient together, and if the patient is remote, then maybe there's a limited network communication. Maybe they have a fixed line, maybe it's via cellular connection, maybe it's Wi-Fi. The mobile phone networks and perhaps the whole connectivity is often not that reliable. And so this leads the problem. For the technology to work successfully, the surgeon needs to view the patient and the surgical instruments in real time to remotely control the robotic arm that he uses to perform the surgery. Obviously, the robotic arm needs to be used safely with precision and accuracy, and if the surgeon was physically present in the room. Any delay on the video stream could be catastrophic, as it might well mean the surgeon is overreaching in terms of some of the surgical procedures, which could prove fatal. So this means three things. The live stream has to be high quality, the live stream has to be reliable, and critically, the live stream has to be viewed with ultra low latency. So when you look at live streaming, one of the major factors is relying on a good network connection back to the surgeon from the patient. But if using the internet for live streaming video, then this cannot be always guaranteed. So, question from my colleague Kerim. What you feel needs to be considered when live streaming over the public network, such as the internet for video delivery?
Yes, usually the robot 1 is in a remote location and robot 2 needs to connect to robot 1 to support or perform the surgery alone. So the distance doesn't allow a local connection, so you have to use public internet at certain point. So you might not have fiber internet at all times. You may need to use 4G or 5G connections. So using cellular connections comes with problem, even though they solve the connectivity problem in most cases. But you cannot expect a fixed stable network latency or fixed stable network speed, especially when you're using mobile networks. Even if you're using fiber line that's more or less more stable than the mobile networks, you still cannot expect everything to go perfect because you're using public internet. What if the bandwidth suddenly becomes smaller? Even momentarily jump in the latency can have an impact in the operation. So you really need to be careful about these things, and you cannot control the everything that needs to be counted. So what you can do is to select a good technology, reliable technology that can prevent or fight with these challenges as they happen. So that's what we provide in summary.
So there are obviously other technologies that can live stream over the public network, whether it's Wi-Fi, 4G, 5G, or even a fixed line. But where Soliton excels doing this is that we do it with high reliability and with ultra low latency. And obviously you have a return network which is doing the control signals, controlling the telesurgery robot. But when you look at those alternative technologies, a typical live streaming solution, especially over cellular, can be between 1 to 10 seconds, which obviously is far too long for safe telesurgery. So to put that in perspective, Soliton can live stream around about 50 milliseconds over 5G and 35 milliseconds with a fixed line. So 35 milliseconds being 0.035 of a second. So, and that I have to just emphasize is the total delay from the camera itself to the screen at the receiving end. And no other technology in the marketplace can currently come that close. So that sort of delay is effectively 1 or 2 frames of video. It's practically real time. There are of course other factors to consider, such as reliability and how quickly a solution can recover in the event of a network glitch, which can be more common than you think, especially on live streaming on a public network over the internet. So there are other technologies that can be cheap, off-the-shelf solution, potentially with an IP camera and a router. These tend to have longer latency, and reliability can be questionable and does not allow for issues such as network contention or even security. Also, other solutions all tend to be hardware based. So With Soliton, we're offering a software SDK, software development kit, which means you don't have to add another hardware element to an existing robot. Basically, the software itself can be integrated and implemented into the existing robotic setup.
Soliton is offering an SDK solution to be implemented inside robot without using additional hardware. So the developers or manufacturers or system integrators can utilize Soliton's technology as a shape of SDK, software SDK. But I would say our core product is the Rasco technology that is behind our SDK. The main product I would say we are offering is that. So Rasco is focusing on solving these problems, these challenges. First of all, when we talk about video streaming, we need to understand that video is a big data and we have to compress it efficiently to stream, to send this video from point A to B, from robot 1 to 2. So we are using the latest codec available in the market, that is H.265. And now that we efficiently compress with the latest codec technology, Rasco also does a couple of other things. For example, in case you're using cellular networks, we can bond, we can combine multiple networks into one network, and we can do load balancing, we can use them efficiently. Rasco also uses error correction because you're using public internet and the bandwidth can fluctuate, the speed can change. So in order to overcome these challenges, we are using error correction, and so we make sure we do lossless transmission over any kind of network. And of course, the bottom line is we do all of these things with ultra low latency, and we don't compromise the quality while we do that. So that's what makes Soliton unique in terms of solving these problems and these challenges. When we say live streaming technology, I want to explain about the processes that go into it. First of all, the camera and the encoder and the transmission, including the network and the decoder and the monitor. So all of these processes actually play a role in live streaming. So Soliton is in charge of encoder, transmission and the decoder part, because we don't provide the camera, but we can work with almost every camera out there. And of course the monitor side is the same. So we can actually specify Soliton as the core live streaming technology provider because of this reason. So I want to explain a little bit further how does it actually work. Camera takes the image, processes it, and gives to the encoder. So Rasco technology is in charge of the encoder because Rasco technology plays a part on the encoder side and the receiver side, the decoder side. We always communicate, so we always check the network situation. Based on the network, we tell the encoder to compress more or less, simply to adapt to the network situation. And when we put all of this image together, so Soliton's technology is in charge of encoder and transmission, checks the network and the decoder. And of course, we need to integrate this core technology on the camera side and on the monitor side. So Rasco is the name of Soliton's protocol. Rasco, as I said, controls the encoder, but Rasco has many features. First of all, Rasco can do bonding. Bonding means we can use multiple networks at the same time. We can combine their bandwidth into one. And we can also do load balancing, where we can check all the networks, each and every connected network's relative speed and latency, and we can distribute the data load between them. So we also use another technology called packet sort. On the encoder side, Rasco, after the encoder compresses the video, Rasco uses special technology to sort the packets, data packets, to be transferred. Receiver side also has Rasco. It also knows this sorting code. So which data packet will arrive from which network connection, receiver side waits for it. And during the transmission, if suddenly network delay is increasing or something happens, then we use error correction technology. Thanks to packet sort and error correction, we can do lossless video transmission. Another aspect I want to take your attention to is security. Because you need to use public networks most of the time, because robot 1 is far away from robot 2, and either you use fiber network or 5G or 4G, you may need to use the public internet. So then the question of security rises. And Soliton's transmission protocol is purely point-to-point, and we provide end-to-end encryption with AES 256-bit encryption. On top of that, we also provide authentication. You can set password on the encoder side and the decoder side as well. So it's very, very secure connection. Raskov protocol is a combination of all of these technologies, I would say. Bonding, load balancing, packet sort, error correction, lossless transmission, in short, encryption, authentication, purely point-to-point connection. Raskov is in charge of encoder. Raskov checks the network. Raskov automatically adjusts all the settings of the transmission. Raskov does not only send video, but it also sends the control signal. So it's very important that haptic feedback will be transmitted back from the local robot to remote robot, or vice versa. So we can actually support serial tunneling. Actually, our developer manufacturer partners can integrate their control signals into our protocol together with the video. So Soliton supports 3D cameras as well, haptic feedback, and on the receiver side, we can also integrate with our partners' existing interface, let's say. So Soliton just provides the core technology and integrates on both ends.
So, in the past at Soliton, we would sell our live streaming technology as a hardware product, with the latest known as the ZAO-X, which is our portable hardware transmitter. But with the ZAO SDK as a software library, we're now selling in effect a project. The software can be OEM'd and integrated into a manufacturer's own robotic device and is highly customizable. Though the SDK is fully documented, because of its versatility and customization, it is normal for our customers to want help and support to integrate into their environment using live streaming best practices that we have learned over the years from many years of live streaming control. At the start of an engagement, customers want to do an easy proof of concept before investing time and money just to prove the Raskov 2 technology works as we say it does. Now this can be done easily by using the ZAO-X. They can connect their own camera, which can be a 3D camera, connect some SIM cards, or connect to Wi-Fi, or connect to a fixed line, and we can provide an easy decoding platform at the receiver end, and they can quickly achieve some initial testing and do their due diligence to prove the technology is a good fit for them. We then treat it as a project. We can look at requirements, and through the majority of development is normally done by the customer, we can help, we can support, and we can recommend solutions that they can then integrate within their robotic design. Now, not every CPU board meets our requirements for the software to work effectively, so often we like to be involved in the early stage of the design to influence the choice of components being considered for the build. Obviously, cost, ease of manufacturing, and availability of parts makes a big influence in the choice of components for the entire project. Soliton is well equipped to help with such decisions, and we can work to a timeline as dictated by the customer. This can also include building a simulator at the receiving end, and the receiving end can be customized around the control signal to include the sensory feedback. So the whole end-to-end solution, we can help. The SDK can be installed on the robot and customized. The receiving end we can customize. So to conclude, contact us and we begin with an exploratory talk about your needs, and then we can come up with a plan from initial proof of concept to final implementation. Just contact us for more information via our website at www.solitonsystems.com.